Okay, so I'd just like to welcome everyone to the Tools and Environment 3 session. Today we have four presentations. We're going to start with PyCocos, a performance portable kernels in Python. We'll then have Gamekins, gamifying software testing in Jenkins, followed by FairKit-Learn, a fairness evaluation and comparison toolkit, and finally Cynthia, a generic and flexible data structure generator. So Nader, I think, will be first to present for PyCocos.
Thanks. So let me share screen. Okay, can you see this?
Yep, I can see it.
All right, thanks.
Your slides. Yep.
So hi everyone, my name is Nadir. I'm a PhD student at UT Austin, and I'll be talking about our work on PyCocos, a performance portability framework for Python. This work was done in collaboration with Neil, who's at Lawrence Berkeley National Labs, as well as Stephen, George, and Milish. So what is performance portability? Well, many of the current parallel high-performance computing frameworks, such as OpenMP and CUDA, all tend to have different APIs, and they target different architectures. And this is a problem because you end up with code that is very tightly coupled to both the API and the architecture, meaning that it is not portable. And say you had an application and then you wanted to move it to another framework or target another architecture. Well, first you'd have to rewrite significant parts of your application to use the new API. You'd also have to learn the new architecture-specific details to get the best possible performance. And then finally, you're stuck with maintaining essentially two versions of the same application. So this approach does not really scale. And what we want instead is performance portability. We want to run the same code on different devices and still get good performance. And this is where Cocos comes in. Cocos is a programming model that enables performance portability by providing layers of abstraction over the existing lower-level frameworks. So basically, it's implemented as a C++ library on top of frameworks such as OpenMP and CUDA. And then any application that is written in Cocos can be run on different devices by simply setting a compile time flag selecting the device or the architecture. Now, Cocos is a very powerful framework. However, not everyone wants to write C++ and deal with issues such as cryptic error messages, especially from templated code, and also manual memory management, among other issues. And in fact, recently, many HPC applications are being written in Python using frameworks such as NumPy and SciPy. And these frameworks give you the ability to quickly prototype your application with relatively small sacrifices in performance. However, there's still no existing solution for performance portability in Python. So how do you bridge this gap between Python on one end and Cocos and C++ on the other? Well, the answer is PyCocos. PyCocos enables developers to leverage the performance portability programming ecosystem that is Cocos from Python. This means that it allows developers to write new performance portable kernels entirely from Python. And it does this by providing Cocos-like abstractions through a domain-specific language embedded in Python. Now, I say domain-specific language, but this really ends up looking like a statically typed subset of Python, as I'm going to show you in a few slides. We implemented PyCocos as a Python framework that is partially connected to Cocos and C++ via bindings for data structures, and this is the main functionality of the PyCocos base package, and partially translated to C++ and Cocos. And this is the main functionality of PyCocos, which is the subject of this presentation. So this is an example of a matrix-weighted inner product kernel written in PyCocos. I'm not going to go over this in too much detail right now. I'll save that for the demo. But for now, I want you to notice these decorators. So up here, pk.functor, pk.workunit, as well as all of these static types that we have in this class and the method. And I'll talk about why we need these in the next few slides. So internally, PyCocos works by translating Python code that is decorated with this pk.workunit decorator to C++ and then compiling it. It also saves these compiled kernels on the file system to avoid recompilation overhead, which can be significant. This translation can happen either ahead of time to the command line or just in time, meaning at runtime when a kernel is called for the first time. Now, this figure gives a high-level overview of the internal architecture and user workflow of PyCocos. So assuming the ahead of time option, first the user passes in the Python files containing the kernels to pkc, which is the PyCocos compiler. which will then extract the kernels into an abstract syntax tree that it will translate to C++ while also generating Python bindings. PKC will then serialize this AST and write it to a CPP file before calling a compiler to generate a shared object file. Now, if this shared object file is not there at runtime, PyCocos will call PKC for the user if they decided to skip the ahead of time option. PyCocos can then import the shared object file and call the kernel and return the results of the execution to Python. Now, we're currently working on emphasizing the dynamic typing and just-in-time approach instead of static typing, as we believe this will make the framework more Pythonic and easier to use. We're actively working on extending PyCocos to include missing Cocos features, while also improving the debugging and profiling experience of PyCocos kernels. Now, since its release last year, PyCocos has garnered an active community of users and developers, and there's major interest from the national labs, such as Sandia National Labs. And just to give you a quick overview of the activity that we're seeing on the PyCocos GitHub repo over the past few months, we've had 11 issues raised by external users, most of which we've resolved, as well as we've merged around 16 pull requests. So in conclusion, PyCocos bridges the gap between Python and Cocos C++, and it also enables entire applications to be written in Python and PyCocos. So you can find more details in the paper, such as code complexity comparison with Cocos and C++, and some more technical details. And yes, PyCocos is open source, and it is available on GitHub as part of the Cocos organization at this link. So now I'm going to move on to the demo. So let me stop sharing and share my other window. Right. So here we have this example that I showed in these slides. And I'm going to, oh, can you see this, by the way?
Yes.
All right, thanks. So I'm going to walk through the basic structure of a PyCocos application. So first, you would import PyCocos as you would a regular Python package. This as PK just tells Python to alias PyCocos to PK. And then to write a kernel, the user must first define a class and then decorate it with this pk.functor decorator. This will tell PyCocos that this class contains a kernel. In the constructor, which is this init method, the user defines these member variables while also using these static types that I mentioned earlier. Now, these are necessary since we're translating Python to C++, so we need to know the types of each variable. So here you can see we have these two integers. So these are primitive types, but we also have more complex types, such as this view, which is basically the array type that is used in PyCocos and Cocos. The constructor here is, so this is the constructor that uses the bindings that I mentioned earlier. The first argument is the list of dimensions. So this is one dimensional, so it's a list of one item. The second argument is the data type. And to initialize these, you can either use this fill function, or you can iterate through a loop and initialize them to a scalar. And now the user can define the kernel, which is a method decorated with pk.workunit. As you can see, the signature contains these types. So J is an integer. This is the unique thread ID. And the accumulator, since this is a reduction operation, this will accumulate the results calculated by each thread. And then the body of the function will also contain these type annotations. And then finally, it will update the result. Now, to actually run this code, first you would have to initialize or create an object of this class, so workload. And then you need this range policy, which basically tells PyCocos how to run this code. So the first argument is the execution space. So this is OpenMP or CUDA. The second argument is the starting thread ID. And then the last argument is the number of threads. And to call this, you would just call parallel reduce, passing in this range policy, as well as the work unit. So w.yax. And then this will return the result. So to run this, all you would have to do is call this like a regular Python application. And since this is the first time we're calling this kernel, PyCocos will first translate the code and then compile it, and then it will finally return the results. Now, the second time we call this code, you can skip this step because we've already done it. And PyCocos will store these kernels in this pkcpp folder. So Now, if we were to run this code with CUDA, so to use our NVIDIA GPU, all I would have to do is just set this default space to pk.cuda. And then I would use the exact same command with the exact same code. So since we're compiling for CUDA now, we need to basically recompile. And then we get the exact same result. And then once again, this compilation only happens once. So now I'm just going to show you a larger example that we've written in PyCocos. So this is ExaMiniMD. This is a molecular dynamics MIDI app that was written in, it was originally in C++ and Cocos. Well, we ported this to Python and PyCocos. So first, let me show you all of our source files. So as you can see, these are all Python files. We did not write any C++. And then to run this, you just pass in the input files. Yeah, basically it will move through the code, calling each kernel. And since this is the first time, it will translate and compile each kernel. And I believe I'm almost out of time, right? I should be taking questions now.
Yeah, if you can wrap up in the next minute, that may be good.
Okay, right. So yes, it will basically translate and compile each kernel. And there's a bunch of them. Yeah, compiling C++ takes a while, so but this should be done soon. And yeah, by default, this is using OpenMP. So, but we can easily set this to CUDA, as you know, setting this default space to CUDA. I believe this should be the last kernel. There's maybe two more. Yep. And then the second time around, if you were to run this again, it would be much faster since we wouldn't really have to call these, wouldn't have to recompile these kernels. So yeah, that wraps up my demo and presentation. And I will be taking questions now.
Yeah, so we have about 3 minutes. If anyone has any questions, feel free to add it to the chat and I can read it out, or just kind of unmute and directly ask the questions, please. So if there isn't any question, I can start with maybe one question to get us going. I see that for PyCocos that it's only working for kind of a subset of Python kind of code. And I guess my question is, how representative kind of is this subset of Python code that's currently supported? And how difficult would it really be to kind of enhance the subset in the future to encompass kind of more functionalities of Python?
That's a good question. So really what we're interested in PyCocos is these high performance kernels that we want to be running on using OpenMP or on GPUs. Now, by default in C++, if you were to write these kernels directly in C++, you'd also have a limited subset of C++. So for example, you're not, in CUDA at least, you're not able to use anything from the C++ standard library. There's specific things you can use, and there's certain things that you cannot use. And in fact, most of the these kernels tend to use relatively simple features of the language. So they don't like using these abstractions because that could cause more overheads. So essentially, this subset is sort of enough to write for writing most kernels, and you don't really need more. Now, how difficult is it to add support to the other features? Well, it depends if we have an equivalent C++ translation. So if we can translate a Python list to something in C++, then that would be relatively easy to implement.
So is everything that's currently supported by C++ also supported then by kind of PyCocos then in this case? Everything that's supported by Cocos, I guess.
So around 60 to 70% of the features in Cocos are currently supported in PyCocos. But we're actively working on adding support for more features. And if a user needs a certain feature, feel free to open up a feature request on our repo.
That sounds great. Thanks.
Thank you.
So it seems like we kind of hit the 15-minute mark, so we're just gonna progress to the next person. So the next one on my list is Gamekins.
Okay, hello. Can you see my screen?
Yep, we can see your screen.
Okay, perfect. Then, hello, I'm Philipp Straubinger, and I'm a PhD student at the University of Passau, and I'm going to present you today Gamekins, a way to gamify software testing in Jenkins. Jenkins is a very popular and open source continuous integration platform, which is used by many projects and many industry and also open source projects. And as you may know, the continuous integration lifecycle is implemented into Jenkins, and I will just show you a simple representation of it. So at first, normally, the developers write some code, change some code, and when this is finished, then they commit their changes to a version control system, and this normally triggers then the test executions, in this case on Jenkins, and depending on the execution itself, it then reports the results back, and they may be good results, so every test has passed, or bad results where at least one test has failed, and therefore the developer will change some existing codes to match the test requirements, or he will be finished with a feature and just move on to the next one. But as you know, test execution needs some kind of test suite in the project. And since the project is evolving over time, of course, also the test suite has to evolve. And you may know from your personal experience that writing tests is not the first task that developers want to do in their project. There are a few reasons why that is the case. At first, software testing is, well, a little recognized, especially by the management and also the customer. And one of the reasons are that writing tests does not really visually impact the project process. So when a developer has tested all day, and in the end, he cannot show a cool new feature to the colleagues or also the customer. And software testing is also perceived as kind of dull and monotonous. So that's why we implemented Gamekins, which is a plugin for Jenkins. And we added some cool new features here to Jenkins. One of them is a so-called leaderboard, where the developers, or the participants in this case, are ranked according to their score they have gained by completing challenges and quests. So a challenge is a small task that Gamekins gives the developer depending on the codes the developers have written, and when they solve the challenges, they will get some points. And the quests then are a sequence of different challenges which have to be solved one after the other. And in addition, also different achievements can be gained while solving challenges and quests, and also just working on the project. I will come to some examples very soon. And well, what do we want to achieve with Gamekins? We want to motivate the developers to write more tests and also increase the quality of the tests. As I said previously, the test suite has to be enhanced over time. And Gamekins proposes this to the developers and gives them a second opportunity to write tests. And when there are more tests in the test suite, then hopefully also the quality of the product itself will increase, because there are more tests and more bugs can be found. And in the end, also the satisfaction of the customer may also increase when there are less bugs and the quality of the product is much higher than before. So without further ado, let's go into a small demo. And I've here my development Jenkins open. I've created a project called Justexe. And as you can see here, I've added a new tab here, the leaderboard. We will focus on this one for now. And let's go into it. And as you can see on the top here, there is the leaderboard itself, where the participants are ranked according to their score and also their completed challenges and achievements. And they can also be grouped into teams. So they can not only compete against each other, but also in different teams against each other. Every participant can also choose himself an avatar, which can be set in his profile settings. When we go down a little bit, we can here see the overview of the current quests and challenges that have been generated by Gamekins. And all of these can now be solved by the developer or the participant. So when we go to the challenges, we have here a so-called smell challenge, which requires the developer to just remove a specific smell or to refactor his code. Next one would be a mutation challenge. We can open it and have a deeper look at it. So we have here the original code snippet, how it is currently in the project. And then we have here a mutation. And now this mutant has to be killed by writing a test. And when this is done, the developer will get 5 points in this case. And we have also the so-called coverage challenges, which requires the user here to write tests that cover specific lines of code in this case, or just increase the code or branch coverage of a specific method or class. These challenges can also be rejected in case it does not match with the current workflow of the project, or it's an unnecessary challenge or something like that. And if we go up a little bit again, we can also see here the quests. In this case, we have here a method quest, which requires the user to solve 3 different method coverage challenges, one after the other. And as you can see here, only the first one is enabled because they have to be solved one after the other. When we go to the leaderboard again, as you can see, each participant has a link here. And when we go on this link, we would jump to the profile of the user and to the achievements of the user. So in this case, I've completed 13 achievements out of 63 in total here. And the achievements are from really simple ones like having one test in your project to some kind of heavy ones like solving a generated challenge a maximum of 15 minutes after it has been generated. So there are really many of these achievements which can be solved. In this case, we have here unsolved, and also on the bottom there would be the secret achievements, which can be solved, or which maybe can be solved by the developers. When we now go back again, we also did an internal evaluation over a period of 5 weeks, and the results were really promising. So the coverage of the project increased by 7% during these 5 weeks. And the total number of tests in the test suite increased by 20%. We also did a small survey in the end, and this showed us that the motivation of all participants, all developers, has increased during the evaluation of Gamekins. And what I'm personally really proud of, every participant found at least one bug in his code or in his tests. So the overall goal to increase the quality of the software has been met here. To give you a short outlook to the future, we are planning to introduce more gamification elements, of course. First one will be levels that we want to introduce that the developers can achieve. We want to enhance the project statistics, especially for the management to see how it is going. We also want to add multiple languages because currently Gamekins only supports Java and Kotlin. And we also want to add more mutation operators so that better mutation challenges can be built. So if you want to try Gamekins, you can just download it via Jenkins. It's published on the Jenkins plugin page. And if you're interested in using it, or also we are always looking for project or industry partners to evaluate Gamekins. So just drop me a mail if you're interested. And thank you for your attention. And I'm now open for questions. Wing, you are muted.
Thanks for the awesome presentation. It seems like we have one question in the chat, and I'm just going to read it out to you. Is it possible to integrate the tool with GitHub so that the challenges are automatically picked up from the project's issue tracker, and when the developer solves the challenge, the commit SHA is recorded against the challenge?
GitHub provides a nice API where we also, of course, can extract the issues. But I don't know if it's possible to also automatically check whether this issue is now solved. Well, you can, of course, create a challenge in Gamekins then, but I think some developer of the project has to manually have a look at it, whether it has been solved or not. But in general, yes, that would be possible.
Yeah, I think there are APIs for GitHub where you can query for what's active and inactive issues and then close them and so forth as well. But
yeah,
very cool work. I have one question myself as well. I'm just a bit curious on kind of, is there some things that kind of Gamekins has to do in order to kind of prevent developers from gaming the system? So kind of potentially just kind of introducing problems so that they can later on fix rather easily. Is there some things that Gamekins does in order to kind of prevent issues like this?
So you mean that the developer can introduce, for example, code smells, which will then be found by Gamekins and presented as a challenge.
Yes.
Currently, since the smell challenges are really new, so about a week ago, I've released this feature. There is no such feature to prevent inserting smells and then also solving them, but that's a good hint. I will have a look at it and add some feature for that. Thank you.
Yeah, it sounded particularly interesting because you were mentioning how one of the results from using it at the company was people were finding their own bugs after kind of Gamekins was implemented. So it just kind of made me think of the fact that what if they were just kind of introducing bugs that they just then later on fix as an overall issue for Gamekins. But yes, very cool work. Thanks for the presentation. I think we're nearing now the 30-minute mark, so we can maybe switch to the Fair Kit Learn presentation next.
First, before I share before I put it in presentation mode, because I can't see anything after that. Can you guys see my slides?
We can see your slides and we can hear you now. Yep.
Fantastic. Awesome. Well, good morning, afternoon, or evening, depending on where you are. Thanks for tuning in. Today, I'm going to talk to you about some collaborative work that was done on a tool called FairKit-Learn, a model fairness evaluation and comparison toolkit. More specifically, I'm going to talk a little bit about what FairKit-Learn is and a little bit, of course, about why it's needed, how FairKit-Learn works. I'm going to also talk a little bit about FairKit-Learn in comparison to other tools similar to it. And of course, talk about how you yourself can explore FairKit-Learn for yourself. So as alluded, I believe in the first presentation a little bit, the data-driven decision-making is very frequent, and we see it a lot in the real world, and we see it a lot in a lot of different domains, critical and otherwise, social and otherwise. And so it's becoming quite pervasive. And as many of us have also seen, with that has come some bias that we want to be able to address, ideally soon and frequently when we're developing technology. And so there's a need for technology or the need for tools that can help us build technology that supports this type of effort or these types of concerns. And so one of the tools that we developed in an attempt to contribute to the solution space for this is FairKit-Learn. And so FairKit-Learn, again, being a model evaluation and comparison toolkit that, given a data set, some models and tuning options for those models, and metrics that you're considering or interested in evaluating these models against, and uses that information to present an interactive visualization of optimal machine learning models based on the metrics that you're interested in. Let's talk a little bit about what FairKit-Learn is and how it does this exactly. So at the high level, FairKit-Learn is comprised of three main components. The first being the machine learning tools that are integrated, specifically scikit-learn and IBM AI Fairness 360. A model search component that conducts a grid search across any number of machine learning model configurations. And finally, an interactive search visualization that provides the output from the search in a way that can be toggled and interacted with by the user. And so I want to talk a little bit about each of these components and what these are with respect to FairKit-Learn. So first, starting with probably familiar to most of us in the audience by this point, the integrated machine learning tools that we used were scikit-learn and AI Fairness 360. Scikit-learn being, of course, a commonly used machine learning library that contains various learning algorithms, as well as performance and quality metrics. And then, of course, AI Fairness 360 being kind of the more frequently familiar, and I would even say foundational, being it's frequently integrated into other tools, machine learning fairness toolkit, as well as fairness-aware learning algorithms. So that's most of what AI Fairness 360 contributes, along with some pre- and post-processing algorithms. So pre being on our data sets and post on the actual models that are the result of our training data sets. And then, of course, the fairness metrics, which is the real kicker here. There's over 70 of them that are provided, and I'm not even sure if this number is up to date or not. This was from, I think, a year ago when we last checked, or even a little less than that. But so maybe there's even more than that, but definitely a large number of metrics that are available, such as disparate impact, demographic parity, and causal fairness, some of the more frequently used or familiar metrics. And so FairKit-Learn takes these integrated machine learning tools to conduct the second kind of major component, or to feed into the major component of the model search. And so the model search is composed of a number of different steps that feed into this functionality. And so first, we start with defining what models we want to integrate. And so this can literally be any number of models from scikit-learn or AI Fairness 360. I've listed a couple examples here, but you can list as many as you'd like, or more specifically, I should say, as many as you have computational resources and time to integrate, because the more you add, the more time and resources it will take to execute and train the models. So once you have your list of models, the next thing that you want to provide to FairKit-Learn are the metrics that you want it to use. And so this comes from a unified metric library that's provided by FairKit-Learn. And FairKit-Learn, again, takes the metrics from scikit-learn, AI Fairness 360, and provides them in one unified library, and also provides functionality for you to add any additional metrics that may be of interest that aren't integrated into these libraries already. And so you can list, again, as many of those as you'd like to include, considering your computational resources and time. You're also able to modify or give parameter options for your hyperparameters, and you do that by model. So for each model, you can select which parameters you'd like to have different values for, and when the grid search is run, it will consider all of those various options that you include. But again, keeping in mind that the more you add there, still the more computational resources and time it will take to train the combinations of models that you provide. Of course, if we want to measure bias, we need to know what we're measuring bias against, not just metrics, but which classes we care about. And so you'll want to specify which are your privileged and unprivileged groups. You'll have to provide a threshold, and the tutorial that I'll point to in a little bit here gives an example of what that threshold might look like, but the threshold gives FairKit-Learn a sense of when to stop, essentially. And then we want to give any of the pre-processing, post-processing, and you don't have to provide these, but if you would like to have any pre-processing or post-processing included, you'll have to specify those as well. And the same goes for the hyperparameters. That is also optional. You do not have to provide additional settings for those. And so once you've set all of those, you feed those into the model search object. That model search object conducts the grid search based on your privileged, unprivileged groups, etc. And then you're going to feed the output of that search into a CSV, which you will both be able to access, as well as then feed into what we use, Bokeh, to provide the search visualization, which is the third and final component of FairKit-Learn. And so once you feed everything into the search method, the grid search method, we get the CSV file that is then fed into Bokeh that then gives us this visualization that you see here. And so let's walk through this visualization and give you guys an idea of what you're looking at here. So the first thing is that you are able to toggle between the various models that you want to see or not see in your visualization. So these buttons allow you to do that. And then you're also able to decide which metrics that you want to see at any given time based on all of the metrics that you included. So this list here shows you all the metrics that you included, and you're able to select really any number, but you will only be able to select 2 metrics to actually display on the graph. So you want these 2 to ideally match, but the thing that's going to be graphed is going to be based on your X and Y axis that you set above. And so once you do that, you're then able to peruse the optimal models that have been provided. In this case, there are a total of 20 models somewhere either in this plot or between the set that has been created from the various metrics that you care about and the various models that you entered. And so from here, you can actually get a sense for your optimal model configurations. And these are each of these dots here, which means your model plus those hyperparameter values if you provided any. And you can reason about which models might be of most interest because maybe you want better fairness, even if the accuracy is a little bit lower. Or maybe you want that better accuracy as long as fairness isn't below some threshold that you've defined. Or maybe you really want to balance both. And so FairKit-Learn provides opportunities for practitioners to kind of make that decision for themselves, but in an informed way. And of course, you can export this plot as well so that you can get the optimal results as opposed to all of the search results. So you can access both of those results. So I just want to talk for a second about the landscape of fairness tools and the fact that there are quite a bit, and you're possibly wondering, well, what's different about FairKit-Learn? What makes FairKit-Learn special? Well, according to a recent study, existing tools aren't always meeting needs of developers and practitioners based on steep learning curves, information overload, and limited support for model development lifecycle. And FairKit-Learn attempts to provide things to support all of those. And I'm running short on time, so I won't talk a lot about the evaluation, but I did want to note that we did evaluate FairKit-Learn to get a sense for how it worked in practice and if it could be beneficial. And we did find some good results there. So feel free to check out our pub for that as well. And also feel free to check out FairKit-Learn because we do have a tutorial and some documentation available to work on that. And I do want to thank, because I do want to have time for questions. So I do want to thank everyone for their time today. And of course, thank those that helped us collaborate and build FairKit-Learn. This was not a individual or even myself and Yuri effort. So thanks. I want to be able to see, so I'm going to take my slides off if that's okay.
Sure, no worries. Yes, feel free to, again, unmute and ask any questions that you may have. Otherwise, feel free to type it into the chat and I can read it out for you as well. So maybe I can start with kind of a question as well, Brittany. So I saw that kind of for a specific model, you may actually come up with a few different kind of points on the plot that you were drawing. And I was seeing that it was essentially kind of the Pareto optimal for a specific model. And it seems to have kind of multiple points. So what I'm curious on is just kind of, what does it mean really when you have kind of, when you really have kind of a Pareto optimal model, but then have kind of different Pareto optimals for a specific model? Mainly when I look at kind of whether or not a model is biased or not, it's kind of either it is biased or not biased against a certain characteristic. So what I'm wondering is, what does it mean to kind of be in between, seemingly, in this case?
That's a good question. I mean, I think that's also somewhat of a loaded question, only because I think one of the things that FairKit-Learn tries not to be is, I think, prescriptive, in that it's hard to be able to say this fairer model is a better model than this maybe almost equally fair, less accurate, equally accurate, whatever the case is. So some of those dots were pretty close, right? And so I don't think it's a question as much of, or an issue as much of, these models are so close to each other, how do I pick? I think oftentimes it becomes an issue of, the space of models is so large, how do I pick? And by having a tool like FairKit-Learn, for example, you make that space smaller such that you can at least reason about, okay, if I select either of these, I'm getting something I'm looking for here. And so maybe which one I select is less important because now I've done some due diligence. I don't have obviously data to back that specifically, but in my head, that's what I would imagine. I don't know if you wanted to add anything to that.
Yeah, can I add just a tiny bit? So there's actually two different aspects that can affect your model. So there's a fundamental trade-off between fairness and accuracy, or whichever metrics you want to pick, in some data, but not in all data. So we've had data sets, in fact, actually quite common, where accuracy and fairness kind of go hand in hand. So you can improve accuracy and fairness does not decrease, right? And so FairKit-Learn can discover that, but you won't see that, like you basically see one point. You'll see that you can maximize accuracy and fairness together. So FairKit-Learn becomes interesting when you do have some kind of a trade-off, right? When making that choice is actually more difficult. So can make things kind of go wrong. There is the data can have a fundamental trade-off between fairness and accuracy, but also, so if I came up with a definition of fairness that basically the reverse of accuracy, right? I mean, it would be a silly definition of fairness, but if I were to come up with that, then obviously they would be pulling in opposite directions and you'd kind of see this line of Pareto optimality that FairKit-Learn would show you. But even if they do go hand in hand, or even if there's sort of a trade-off that you're trying to understand within the data, by setting your parameters unluckily, or by using a bad algorithm that doesn't find the best solution, you might get a bunch of suboptimal points. So what FairKit-Learn helps you do is it helps you separate those two things. So by doing, let's say, grid search, by trying lots of different learning methods and by trying lots of different hyperparameters, it'll kind of get rid of those bad choices that you might have made on the machine learning side, and it helps you see the true contour of what is the trade-off between the particular parameters you pick. And the point of FairKit-Learn is to fairness with accuracy, but you could use it to balance precision versus recall, right? It could be completely independent of fairness. You can pick any metrics you want, or you could say, you know what, I don't care about accuracy. I care about 3 different measures of fairness, and you can just balance those. And so again, so there's two things that could go wrong. There's the actual learning process that can go wrong, and the job of fair-cut-learn is to try to eliminate that going wrong. And then there's the second thing, which is the data. And when I say go wrong, what I really mean is what can cause your method to be unfair or to be inaccurate, right? So it could be the data, and we're trying to really help people understand the underlying trends in the data so that they can take that and understand those things, taking the machine learning possible errors out of it.
Yeah, thanks for the very detailed answer. I was mainly just thinking whether or not you have those Pareto optimals because you have multiple characteristics, and then if you want to kind of be unbiased against one, you may be biased against the other or something like that. But it's interesting that you mentioned that accuracy and precision and recall and stuff were also things that that Faircut can consider. Very cool work. Thanks. I think we're short on time now, so we're going to move on to the last presentation. Sylvain, I think, will be presenting Cynthia now.
Okay, so let's share my screen. Okay, so you can see my slides?
Yes, we can see your slides.
Great. Okay, so let's go. So hi, my name is Sylvain Allais from Université du Québec à Chicoutimi in Canada. Today I'm going to give you a demo of Cynthia, which is a Java library that can be used to generate synthetic data objects of various kinds. And this is joint work with one of my students, Marc-Antoine, who is also in the attendance today. Okay, so what kind of data can we generate with Cynthia? And the short answer is pretty much any Java object you like, provided that a generator exists for it. So the core of Cynthia provides generators, or pickers as we call them, for various common objects. So you can generate numbers, booleans, character strings, lists, trees, graphs, etc. And if you cannot find a picker that suits your needs, you can also create your own. So in the next few minutes, I will give examples of some of Cynthia's features that make it stand out compared to other approaches. And as we will see after the presentation in the demo section, all these examples can be found online in the repository of code examples that comes with the API documentation. So we're going to see this in a few minutes. The first interesting feature of Cynthia is its modularity. So its architecture is based on, as I said, the notion of a picker, which is an object implementing a single method called pick. So its task is to return an object of a given type every time it is asked. So the interesting part is that pickers can be instantiated by other pickers and use them as a source of choice. So here we have a simple program that generates a list of two-dimensional points. So as you can see, it takes actually two values, one for the radius, it's a point in polar coordinates. So it takes a radius and an angle, and given these two things, it produces a two-dimensional XY point for it. And you see here examples of the instructions in Java that you need to write in order to create this generator. So the box at the bottom is the picker that generates points based on a circle radius and an angle. And other pickers connect to this one and determine how this radius and angle are selected for every point. So here each is based on the generation of a random number. That's what you see. So for example, the picker at the top left here, the dice means pick a random integer in some interval. And what you see here, the straight line is pick a random floating point number uniformly in the unit interval and then apply some transformation to it. So here, if I run this program, so I would get a list of points. And if I drew these points, I would get plots like the ones that we can see at the bottom of the screen. Now, the interesting thing is that if I change the way the picker is wired to other pickers upstream, I will get other patterns of points, as you can see in this other example. So I completely changed the way in which the values for R and theta are generated. And what this yields is a set of XY two-dimensional points that follow a completely different pattern. So just for fun, here's another more complex example. And this chain in particular simulates the operation of an AM radio. And here's another one here where you can generate a random scale-free graph that simulates the map of a website. And then once we have this graph, there's another part of the pipeline that generates multiple random walks in this graph to generate what amounts to a fake web server log. And you can note in each case that the chain is instantiated at a relatively high level of abstraction, and it contains relatively few lines of code. Another important feature of Cynthia is what we call explainability. So every object produced by a chain of pickers and even parts of an object can be retraced to the precise upstream objects and values that contributed to its creation. So here is a code example where I create again a list of two-dimensional points in a different way. So first what I do is that I instantiate, so this piece of code here is the instantiation of the chain of pickers that I want. Then what I do is then I run this thing. I ask for a few values to get a list of points. And the interesting part is the last 3 lines of code. So first I designate a part of the first output list, namely its first element. And then I ask Cynthia to give me an explanation which takes the form of a graph. So if I run this, what I get in the console is actually the description of a graph that describes where this value comes from. And this tree can then be rendered, for example, using GraphViz, and it would produce a graph like the one that you see here at the bottom of the slide. And this comes built in with Cynthia, and as you can see, it requires a single instruction. Basically, what I do is I have objects that allow me to point to parts of values produced by pickers, and then each picker is able to give me the source or the explanation for that part of the value that has been generated. A third feature that I will talk about is called input shrinking, which is similar to what can be done in implementations of the quick check framework. So here is an example where you have a list of integers that are randomly generated until one is found that exhibits a fault in the underlying sorting algorithm. And so the pickers implementing an interface called shrinkable can automatically produce smaller values. And the repeated search for smaller and smaller values is automated by an object called assert. The way in which the shrinking proceeds is also special to Cynthia. I won't have time to go into the details of how it works, but it's described in the paper. So if I run this again, I will see I see that the assertion, so lists are generated and one of them fails the assertion, and then there's an automatic shrinking that proceeds and that manages to find a smaller example, so a smaller sublist of the original one that still exhibits the same error. Cynthia can also shrink sequences of actions sent to a reactive system. So the sequence of action is produced by generating random derivations of a grammar, and this is also a built-in feature. And once a failing sequence is found by another object called monkey, then the search for a smaller sequence proceeds automatically. And as with any shrinking in Cynthia, the shrunk input preserves the properties of the original. So any smaller sequence that is being tried is a subsequence of the original, but a subsequence that is still a valid derivation of the grammar and not just any subsequence. Here are some of the things that the library can do. And I see that I have like about 1 minute left, so I can maybe go to the code examples. So like I said, there is a website where the API documentation of the library is available. And along with this documentation, you also have detailed and commented code examples for the various generation features that are inside the library. And so if I go, so you can read the documentation about each of these examples. For example, here you have one variation of the generation of two-dimensional points according to one possible way of wiring pickers together. And all these examples, of course, come with code. So if I go here in Eclipse in the code examples, you see this is variation number 1. And indeed, you have the example of code. So how you instantiate pickers together, and then we extract here 100 different values. So if I run this thing, I get the list of points, and then I could illustrate this. I could plot these points and get a pattern that looks like the one you see here. You have other examples. So the oscilloscope, so just for fun, the AM radio that I was talking about here. So you have, again, the code example that generates. So there are other pickers that I didn't have time to talk about, but you can, for example, generate sine waves or just incrementing values and things like that. So if I run this example here, I will get the pattern that was described. And if I change the way the picker that produces this sine wave is connected to upstream pickers, I would get a different kind of signal. So that's why I'm saying that it kind of simulates the behavior of an AM radio. So you also have examples where you can generate sentences according to a grammar, like I said earlier. So here you have the description of a context-free grammar. And then if I run, and you see that you have very few lines of code if you want to generate sentences from this grammar. And then if I run this thing, I will get 10 randomly selected sentences from the grammar. So this gives you an overview of the kind of things that we can do. So the main concepts are those of pickers and the pick method and the shrinking process. But then it can be derived in various kinds of ways to generate all sorts of objects, and then be connected together in different things to generate different patterns for these objects. So I think my 10 minutes are done. So thank you for listening, and I'll be happy to take questions.
Great. Thanks for the presentation. Yeah, we'll take any questions as before. Feel free to, again, unmute and ask, or just ask any question you may have in the chat. I can maybe, again, start with the question here. So one of the things I'm curious on is just kind of what kind of future work is maybe planned for kind of Cynthia? Is kind of integrating it as part of a test generation tool, something that the two of you have in mind, or is there kind of something else as well?
Yeah, we have. Yes, there are three main directions where we would like to do some more work on Cynthia. The first one is indeed trying, for example, to interface with JUnit so that you could generate test inputs based on pickers that would be written as a chain of Cynthia pickers. So that would be one interesting thing to try out. The other one is obviously extending Cynthia so that we have generators or pickers for other types of objects. And basically, we use this library in many other research papers when we do simulations for other things that we do in our researches. And these are occasions to add more functionality to the library as needed for these different papers. So that's another direction of research. And the other one that I would find interesting, but it is much more speculative, would be trying to, since pickers have parameters, most of them have parameters. One interesting thing I would like to try is to try to fit parameters so that you generate objects that are similar to a reference, let's say, real-world set of data. So let's say, for example, that you have real-world web server logs, and then you create a chain of pickers, and you want to generate logs that look like the ones you already have, the real-world ones. So one interesting thing would be trying to tweak the parameters so that you end up with a chain of pickers that makes the logs most similar to the real ones. So try a kind of search process where you would quote unquote discover how to instantiate pickers and what parameters to give them so that you end up generating things that are faithful to the real world thing. So I think that's more speculative, but that's something the Cynthia would allow to do.
In addition, we also developed a program to use Cynthia with the apartment simulator. So it's a program that use a script to simulate the interaction with people in the demotic environment. So we use Cynthia to generate to automate the generation of script for that program.
I
Any
see.
other
Very
question?
Cool. Yeah, that answered my question for sure, at least. Yeah, any other questions maybe from other people?